Stay up late though it rains. It's good, but it is never the same. Never really the same.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now let me do two examples for you in predicting the aromaticity of a molecule. So let's start with naphthalene right here. Does it have a closed p orbital loop? Yes, it does have closed loops. Is it planar? Is it in the plane of the board? Yes, it is. And now we can do the pi electron count. So we have 5 carbon-carbon double bonds, right? 1, 2, 3, 4, and 5. Each have 2 electrons. So we have 10. And we have 4n plus 2 being the magical rule. And if n is equal to 2, which is the number of electrons, we end up with 10. So yes, naphthalene is indeed aromatic because it follows the 3 rules that I talked about before. So now let's look at furan. So in this case, yes, we have a closed p orbital loop, and this oxygen can actually be in an sp3 configuration where there's no p orbital, or it can be in an sp2 configuration with 1 lone pair in the p orbital and 1 lone pair in the sp2. Is it planar? Yes, it is in the plane of the board. And let's now do the pi electron count. So we have 2 carbon-carbon double bonds right here. And so we have 2 electrons times 2, and we have 4. And we also have 1 lone pair on the oxygen, which I'm going to draw in like so. So the 1 lone pair on the oxygen gives me 2 more. So when you add this up, you end up with a total of 6, and thus it fits in with 4n plus 2 when n equals 1. So we have 6, and this is indeed an aromatic molecule. So in the case of furan, we have to indicate whether this oxygen is in an sp3 or sp2 configuration, and that will determine whether it's planar or not. And also remember to indicate that there's a lone pair on the oxygen in order for that to be included in the count.